Good morning. I hope you're enjoying our virtual field day so far. As you can see, this is not a Zoom virtual screen. This is an actual strawberry field during harvest. My name is Gerald Holmes. I'm the director of the Strawberry Center, and my topic today is Botrytis gray mold. The worst thing that can happen is the grower puts all the effort into growing the crop, harvesting the crop, cooling and shipping that crop, only to have problems with arrivals. So what we did is we looked at the conditions in the field as they relate to post-harvest occurrence of botrytis. Things such as temperature, leaf wetness duration, rainfall, and fungicide application timing and frequency. Let's get started. Botrytis fruit rot is the most important fruit disease of strawberries worldwide. And it's a really easy disease to diagnose and to find in the field, except when it's hiding underneath the calyx like you see here. You see the calyx is wet, that petal got stuck there and the moisture got trapped, and eventually that will decay. Botrytis is everywhere and it's just looking for an opportunity. And no matter how good the pickers are, no matter how conscientious, some of that will escape detection and end up in the clamshell. It's unavoidable. The most common way that the disease is managed is through the use of fungicides. This is a very expensive thing to do. It doesn't always give us the results we want, and we wish there were more reliable means of controlling the disease. Each year at Cal Poly, we conduct fungicide performance trials against botrytis, and one thing we've noticed is that some years there isn't very much disease. As a matter of fact, out of the 10 trials you see here, only 2017 was there a relatively high level of disease. Look in 2018, in both the spring and the summer, there were no disease in the field. So we decided to do a survey because we think that maybe we're spraying fungicides more frequently than needed. We thought that if we looked at the incidence of post-harvest botrytis, by simulating commercial handling practices, we could get a handle on this, knowing that some of the botrytis is going to sneak through and get into the clamshell, right? So we wanted to know when the peaks of botrytis fruit rot occur on a commercial level in relation to temperature, rainfall, leaf wetness duration, and the fungicide programs. To do this, we set about doing an industry-wide survey in all 3 districts, starting in January and up to the present. We've selected 12 sites, 4 per district, and at each site we have 4 sampling locations where we take 4 clamshells. What that ends up giving us is 16 clamshells or 2 trays. And I'd like to thank the collaborators, Dan Lagarde and his team, Miriam, Daniel, and Ignacio, as well as the growers and PCAs who are letting us in their fields to do this work. Not to mention, also here at Cal Poly, our students and staff, especially Dr. Hewa Vitharana, who is leading this project. Here are the 12 sites we selected, 4 in each of the 3 districts. There's different varieties and different growing practices. I want to point out the 3 pairs, 1 pair in each of the districts. In Oxnard, we have the same variety, Fronteris, but with different growing practices. In one case conventional and the other organic, and you see that repeat with Monterey and Santa Maria and with Plant Sciences 9271 in Watsonville. So this is how the assessment works. You start with those 2 trays with 8 1-pound clamshells. Those come directly from the field and are immediately transported to Cal Poly. At Cal Poly, they're put in an incubator at 34 degrees Fahrenheit for 7 days. That is the standard storage temperature for strawberries, but 7 days is longer than most, the longest shipments. Coast-to-coast shipments are about 4 days, but when we tried that temperature, we weren't getting any decay, so we needed a little more sensitive assay, and we extended the storage period to 7 days. After the 7 days, the fruit are assessed for the presence or absence of botrytis. Just to give you a benchmark of the amount of decay that one would likely see, this is a pallet with 108 trays of the 1-pound clamshells. And what's typical in a cooler is the quality assurance team will take a clamshell at random from the bottom layers, another clamshell from the middle layers, and a third clamshell from the upper layers. And they'll take those, and assuming that those clamshells have 20 fruit per clamshell, there's more larger fruit in the beginning of the year and smaller fruit at the end of the year, but 20 is a good average. Now, if you found 2 fruit in those 3 clamshells of 20 fruit, you'd be exceeding the USDA #1 standard for decay. Actually, 2 in 60 is 3.3% decay. Okay, so with that behind us, you know the methods. What are the data? So we have 2 ranches here in Oxnard. The blue, will use the same color scheme throughout. The blue is the organic and the red is the conventional. The USDA #1 standard is there at 2% for reference. Now let's take a look. That's the conventional, and this is the organic. And this is the most dramatic out of the 3 regions where you see a big separation between organic and conventional. And when I say organic, I mean no fungicides were used in this case. We know that there are organic fungicides, but in this case, no fungicides were used. So in 3 different instances, the levels went way above, and 15% incidence of botrytis is huge. Now looking at the incidence of botrytis as it relates to rainfall, the rainfall is the blue line, and the botrytis incidence are the gray bars showing exactly what you saw in the previous graph, but now in relation to rainfall. This is the conventional field, so rainfall there at 2 or 3 instances, and now the USDA standard there at 2%, and this is the organic field, showing again the rainfall coinciding with the incidence of the disease. Let's go now to Santa Maria. Same thing, Ranch G is in red, Ranch H is in blue. You can see that the conventional stayed below the 2% the whole time, and also the organic stayed low. Only in 1 instance did it rise above 2%. Now if we look at that in relation to the rainfall, that blue line, you can see there was rainfall early, but it really didn't amount to much disease in the conventional. And you'd think that that might be because they're fungicide, but in this case it looks like the organic had just as low as the conventional. Looking at Watsonville Salinas now, the organic again in blue and the conventional in red. And you can see just basically neck and neck throughout the entire season. So it didn't matter in this case if you used fungicide or not, or it didn't matter very much. Okay, looking at the rainfall in relation to that, you see that again, the bars stayed relatively low. The rainfall came mostly ahead of when the disease was, which makes sense since that's when the flowers are infected. This is the organic farm, same exact rainfall because these fields were very close to each other. Okay, so what do we make of this? There's more work to do, but our initial observations are that the botrytis levels are very low most of the time, but with some important exceptions. The fungicide application was really not associated with botrytis fruit rot levels during periods of little to no rainfall. And that most importantly, we believe that there's potential to dramatically reduce fungicide application without affecting botrytis levels. So from here, we need to take a closer look. We're still collecting data on fungicide use. That takes time because of the county reporting systems. But we think that there's a story here to tell. And at the end of the day, where we're going is we think that we will be able to dramatically reduce fungicide application without affecting botrytis levels. And that's pretty exciting.